Finding zeros of polynomial functions is putting everything that we've learned all together. We are going to use our calculator to make it a little bit easier. You could create a list using the possible rational zero theorem, but we're going to find what I call the easy zeros in our calculator. Before we get started, we're going to look at our highest degree, which is 4. And the fundamental theorem of algebra says that our highest degree will tell us exactly how many zeros that we have. They could be repeated zeros. They could also be imaginary, but we should definitely be able to find 4 of them. Now, real zeros are the ones that touch our x-axis or cross the x-axis. So we're going to use our calculator and find the easy zeros. So I plug in the function to our calculator, and I'm going to hit graph. My graph is zoomed in right now, and I see that my graph crosses 4 times. So I know I have 4 real zeros, but I'm not sure what all 4 of them are. It appears that this is a -1 and this is a +1, and this is some sort of fraction or decimal between -1 and -2, and it looks to repeat itself over here. Let's go to our table and see if we're right, and you'll see that -1 is a 0. Remember, a 0 is where your function, or y, equals 0, and +1 is also a 0. So we're going to use those as our easy zeros. So x equals -1 and x equals +1. Next, we're going to use synthetic division. Every time you do synthetic division, you will lower the degree of your polynomial by 1. And if we can bring this degree down to a 2, we can easily solve any quadratic using the quadratic formula. So let's get started. Synthetic division, we're going to put our 0 on the outside. So we're going to put -1, and then we do this half box, and we're going to put our leading coefficients inside. Now we have x to the 4th, so the coefficient there is 1. There is no x cubed term, so we're going to put a placeholder of 0. X squared has a coefficient of -3. There is no x term, so I'll put another 0 as a placeholder, and then our constant is 2. First thing I do is bring the first number down, and I begin. 1 times -1 is -1, and I add down. -1 times -1 is +1, and I add down, and I get -2. -2 times -1 is +2. I add down, I get 2. 2 times -1 is -2. I add down, and I get 0. Remember, this very last number is your remainder. Now, you should get a remainder of 0 because we know for sure that these are both zeros or roots of our polynomial, and so this should turn out to divide in evenly. What we have down here is a new polynomial, and we could put our x's back in. If we did, this would be x cubed, x squared, x, and our constant term. However, this is still a cubic, and I'm not quite sure how to factor a cubic or solve one, so I'd like to bring it down to a quadratic. So I'm going to do synthetic division one more time. You don't even need to rewrite it. We're just going to make another half box here, and we're going to put our next 0. So we're going to put this guy over here, +1. And we are going to do another level of synthetic division. So I'm going to bring this first number down, 1, and I'm going to get started. 1 times 1 is 1. I add down, I get 0. 0 times anything is 0. Add down, I get -2. -2 times +1 is -2. I add down, I get 0. Remember, this is your remainder. And we have now created a quadratic. So this is x squared. There is no x term, so -2. And if we set that equal to 0, we can easily solve. So if we add 2 to both sides, we end up with x squared equals positive 2. We can take the square root of both sides, and x is going to equal positive or negative square root of 2. Anytime you do the square root of an x squared, you have to account for the positive and the negative. And so if you have a quadratic like this and you use the quadratic formula, you should have two answers. X squared, the 2, the degree, tells you you should be able to get 2 zeros out of that, and we have. We can easily write all of our zeros as a list. We have 2 of them over here. We can add the 2 we just found. So one of them is square root of 2, and the other one is negative square root of 2. If our question wants us to write as a product of factors, we can also do that. So we can turn x minus 1 into a factor, and that is x plus 1. We can turn x equals 1 into a factor, and that would be x minus 1. We can turn square root of 2 into a factor, and that would be x minus the square root of 2. And this one would be x plus the square root of 2. So here is a polynomial function in factored form, or here is a list of all 4 of the zeros of this polynomial function.